Divergence theorem. Suppose V is the volume bounded by closed smooth curve S. Then the double integrations f dot n cap ds. This will be equal to double integration V del dot f dv. And we can also write this is equal to divergence of f dv, where n is outward normal to the given surface unit vector. Now first we define the volume integration and surface integration for some given figures. First we take cuboid. Then cuboid, if it suppose that the length is A, breadth is B and height is C. In that case we always take the integration limit as x equal to 0 to A, y equal to 0 to B and z equal to 0 to C. Okay. Now we take the cylinder. This is the cylinder. This is surface S1, S2, S3. We want to find out the volume integrations of this and surface integrations. First take the volume integrations. In case of volume integration, we will suppose that x equal to r cos theta and we suppose that y equal to r sin theta, right? The limit will be equal to z equal to 0 to 2 or you can say 0 to h. If I take the height as h, so we will take 0 to h like this, 0 to h. R, radius 0 to a and theta is 0 to 2 pi because theta will cover the circle and we will take, if we will take whole the circle, whole cylinder, then we will take 0 to 2 pi. And dv will be represented as r, dr, d theta, dz. This is dv. This is the value of dv. And we put the functions here and then we can find out the volume integrations. If we want to find out the surface integrations, for this one we want to find out the surface integrations. This is the cylinder like this and we want to find out surface integration for this surface, that is S1 surface. And the equation of this surface is x square plus y square equal to a square, and let us suppose we say z equal to 0 to h. Then we will take, because the surface for forming this surface we will take a ring, and if we just integrate ring from 0 to h height, this height, then we will get the surface. So suppose x equal to a cos theta, y equal to a sin theta. Suppose this one. Here we take, in case of volume integration, we take r cos theta and r sin theta, and in this case we take a cos theta, a sin theta. And ds will be equal to a d theta dz. You can see here dv equal to r dr d theta dz. Put r equal to a and just skip this dr, we get a d theta dz. So write here a d theta dz. Limit of theta will be 0 to 2 pi for whole circle and limit of z will be equal to 0 to h. Right? If I want to take the this cylinder in first octant, in first octant the limit will be changed as theta will be from 0 to pi by 2, because first octant means in coordinate system xy coordinate there will be the first quadrant. The limit will be 0 to pi by 2 and z will be equal to from 0 to h for first octant. Now we take the sphere. The equation of sphere is x square plus y square plus z square equal to a square. X equal to r sin theta cos phi, this is the cylindrical coordinate. Y equal to r sin theta sin phi and z equal to r cos theta. As we know that the Jacobian of this one, we earlier find out the Jacobian of this one is equal to r square sin theta, right? R square sin theta, that's why we can write dv will be equal to r square. You can write this dv equal to r square sin theta, this is the value of Jacobian, and dr d theta d phi, right? This is the value of dv. And limit of r, what will be the limit of r? Limit of r is equal to 0 to a, radius r equal to 0 to a. Theta, what is theta? Theta is basically the angle with z axis. This is the, let us suppose, z axis. If I say this is r, this angle is theta. If I want to take first octant, then take theta equal to 0 to pi by 2, and if you want to take the whole the sphere, then we will take 0 to pi. What is phi? Phi is the angle in the circle of this xy plane. This is the phi angle. If you want to take the whole circle, write this 0 to 2 pi. If you want to take the first quadrant, then you take 0 to pi by 2. Clear? This represents the circle. Now we come here the surface integration. In case of surface integration, because surface integration will form from the ring. So I will take here with in place of r, you take here a. We suppose x equal to a sin theta cos phi. This is x, this is y, a sin theta sin phi, and z equal to a cos theta. So ds will be equal to parallel to this dv. You can see here dv is r square sin theta. So we take r square as a. So a square sin theta, skip this dr, and we get d theta d phi. By this you can find out the surface integrations of the sphere. Now if I suppose that we want to take hemisphere, what will be changed? In case of hemisphere, r will be 0 to a and theta will be 0 to pi by 2 because we will take the positive z axis, and phi will be same. In case of sphere in first octant, what will change? Theta will be 0 to pi by 2 and phi also 0 to pi by 2 because we will take the 1/4 of the circle. So we will take 0 to pi by 2. Clear? For solving these types of integrations, only two formula required. Formula number 1, that is 0 to pi by 2 sin की power p theta cos की power q theta d theta. Formula of this one is gamma p plus 1 by 2 gamma q plus 1 by 2 upon 2 times of p plus q plus 2 upon 2. This is the first formula. This one is the second formula. You know that for definite integration, if you want to just halve the limit, here is limit 0 to 2a fx dx. You can write 2 times of half the limit 0 to a fx dx if f of 2a minus x equal to fx, and this is equal to 0 if f of 2a minus x equal to minus of fx. We will apply this formula for changing the limit from 0 to pi to 0 to pi by 2 or 0 to 2 pi to 2 times of like this 4 times of 0 to pi by 2. We will apply this formula 2 times, then we get this one, and if we have 1 time, then we will get 0 to pi by 2. Because we want to apply the formula 0 to pi by 2 sin की power p theta cos की power q theta. Okay. Now we take example. Let us suppose f is given as 4xi minus 2y square j plus z square k taken over this one x square plus y square equal to 4, z equal to 0 to 3. It will represent a cylinder with cylinder height as 3, okay, and this circle, radius of this circle is 2, and its equation of this circle is x square plus y square equal to 4. For taking right hand side, first find the divergence. Divergence with del dot f. So del dot f, this is basically f. What is del dot f? Del is, what is del? Del is I del by del x plus j del by del y plus k del upon del z. That means we will differentiate I component with respect to x. So if we differentiate 4x with respect to x, we get 4 like this minus 4y plus 2z. This is the del dot f. Taking 2h common, we will get this one, right? Now we want to solve this integrations as we discussed earlier. In this one, for cylinder we will take x equal to r cos theta, y equal to r sin theta, and dv equal to r d theta d phi dz. Apply this formula here. So I take this x equal to r cos theta, y equal to r sin theta, and dv equal to r dr d theta dz. Right? Put the limit here. This is take 2 times. Z equal to 0 to 3, 0 to h, theta 0 to 2 pi, as we discussed earlier, r 0 to radius a. And put the value of y here in terms of theta, 2 minus 2r sin theta dz r dr d theta dz. So first we will integrate with respect to r. So integrate with respect to r, we will get 2 का हो जाएगा आपके पास आपका r is in multiplication, तो we get r square by 2, here r cube by 3 second term, this is r square by 2, and put limit 0 to 2. If we put the limit, we will get this one 4 minus 16 by 3 sine theta, and this one minus 2z. Now this limit is theta equal to 0 to 2 pi. Now I want to apply the formula for 0 to 2a fx dx. And here fx is equal to sine theta for the second term, this one. F of what is the 2a? 2a is 2 pi. If I take 2 pi minus theta, that is sine of 2 pi minus theta, that is equal to minus of sine theta. So that's why the value of this integration, the middle integration will be equal to 0. So you can say value of this integration is 0 for 0 to 2 pi. It's clear? Now there are the two terms remaining, 4 plus 2z. Take 2h common. 4 plus 2z is this one, and theta 0 to 2 pi. Integration is theta, and we will put the value of theta is 2 pi. We will get 4 pi. Now integrate this 4 plus 2z with respect to z, that is 4z plus 2z square by 2. Put limit 0 to 3, we get 84 pi. This is the value of integrations. I want to prove the left hand side. In left hand side, the integration is double integration f dot n cap ds. There are the three surfaces in the cylinder. First surface is this one is S1, let us suppose. This surface is S2, and the cylinder surface is, this surface is S3. For this S1, z equal to 0. For this S2, z equal to 3. Take for S1, z equal to 0. N cap. If I take, this is the x-axis, this is y-axis, this is z-axis. Above this one is z-axis. So you can see that n cap, outward normal, is minus of k cap. F dot n cap, if I take n cap this, so z square into minus k into k, that is minus of z square. Put z equal to 0, the value of integration will be equal to 0. Okay. So first integration for S1 is 0. Now it comes to S2. What is the change in S1 and S2? In S2, z equal to 3. Here is z equal to 3. So put here z equal to 3. N cap is k, because outward normal is this side. This is the outward normal in this case. This is k. In this case, outward normal is this one, that is minus k. Okay. So f dot n cap is z square. If you put value of z square is 9, we get double integration s ds. We take 9h common and double integration of s, this one, it will represent the area of the region. And what is the area? That is circle with radius 2. We can say 9 into pi. What is the area of this circle? That is pi r square. R is 2. We get pi into 4. So we will get 36 pi. This is the answer. Now we take the S3. S3 surface is the cylindrical surface. The equation of this is x square plus y square equal to a square. First we find out the n cap. For n cap we find del S3. Del S3 is 2xi plus 2yj. And n cap is equal to, if I divide this one, 2xi plus 2yj, and this upon square root of 4x square plus 4y square. Put the value of x square plus y square equal to 4. So we will get outside h2. So we will get from here xi plus yj upon 2. This is the value of n cap. F dot n cap. F dot n cap is 4x square minus 2y cube upon 2. That is 2x square minus y cube. Right? Now we want to find out S3 2x square minus y cube ds. Because this is the surface integration, as we discussed earlier in case of cylinder. You can see here, we discuss here, in case of cylinder we will take x equal to a cos theta and y equal to a sin theta and ds equal to a d theta dz. Right? Take a d theta dz, apply this formula here. For the surface integration, apply here this one. Put here x equal to a cos theta, where a equal to 2. You can write this x equal to 2 cos theta, y equal to this 2, this is 2. X square means 8 cos square theta minus 8 sin cube theta. And what is the value of ds? Because value of ds is ds equal to a d theta dz. Value of a is 2, so 2 d theta dz. Put here 2 d theta dz. Taking 8 into 2, 16h common. This is the integrations. Now you can see that the limit of integration is 0 to 2 pi. We want to convert this limit from 0 to 2 pi as 0 to pi by 2. For this, apply this formula 0 to 2 pi sin cube theta d theta. And you can see that f of 2 pi minus theta, that means sin 2 pi minus theta, this whole cube, that is equal to minus of sin cube theta, this one. So the value of integration is equal to 0. So this second integration will be equal to 0. We get only cos square theta, and apply this formula 0 to 2a fx dx, this formula 2 times. We get 2 into 2 4, this is 4, and this limit 0 to pi by 2. Apply the formula 0 to pi by 2. What is the formula for 0 to pi by 2? The 0 to pi by 2 formula is, this one is 0 to pi by 2 sin ki power p theta cos ki power q theta, that is equal to gamma of p plus 1 by 2 gamma of q plus 1 by 2 upon 2 times of p plus q plus 2 upon 2. So apply here p is equal to 0, q equal to 2. This is gamma 1 by 2, gamma 3 by 2, 2 times of gamma 4 upon 2. We get this, gamma 1 by 2 is root pi, gamma 3 by 2. What is value of gamma 3 by 2? That is equal to 1 by 2 root pi. We will get 1 by 2 pi, and here 2 times of gamma 2 is 1. 1 by 2 pi upon 2, and the function is now 1, the integration is z, and z equal to 0 to 3. And put here the value is 48 pi, and total integration value is first integration 0, second the 36 pi, third one is 48 pi, that is equal to 84 pi. So this is verified. Clear? So like this we can solve by the Gauss divergence theorem. You can take the other example as, let us suppose I say f is equal to x square minus yz, this I, and plus y square minus zxj plus z square minus xyk, this is, and S is the surface, x equal to 0, x equal to a, this is a cuboid, y equal to 0, y equal to b, and z equal to 0, z equal to c, cuboid. Remember, let us suppose we want to verify Gauss divergence theorem. Gauss divergence theorem. We want to verify this theorem, right? What is the Gauss divergence theorem? First write the Gauss divergence theorem, that is equal to double integration s f dot n cap ds, that is equal to triple integration v del dot f dv. For left hand side you will solve the 6 surface, okay, and for right hand side we will solve the only one integration, that is triple integration. We have the 6 surface. For left hand side we will solve this all 6 surface, and right hand side one integration. So I am solving only the right hand side. Del dot f. What is the value of del dot f? The differentiation of this with respect to x, that is 2x. Differentiation of this with respect to y, that is 2y, and next one is 2z. This is del dot f. Okay. Now the integration is triple integrations. As you know, this is a cuboid. The limit of this is from 0 to a, 0 to b, 0 to c. So let's write the limit. X equal to 0 to A, Y equal to 0 to B, and Z equal to 0 to C. 2 ले लेते हैं outside, that is x plus y plus z, and dv will be equal to dx dy dz. So can say dz dy dx. Okay, and we can easily integrate this one, and we will get the answer is abc a plus b plus c, like this. For surface integration, we will find out the 6 integration and then we can verify this theorem. Okay, the 6 surfaces, let us suppose this is S1, this one is S2, this is x-axis, let us suppose this is y-axis, and this is z-axis. This surface is, let us suppose S3, this one is S4, this is origin, and let us say O, A, B, C, D, E, F, G. You can solve this one. For S1, n cap is minus k. S2, that is k. S3, left hand side, this one, that is minus I, and let us say S4, that is plus side, and like this. You can find the n cap and then find the left hand side integration. Okay, thank you very much.